Hello, welcome to the third part of the Deep Rising Introductory Training series. In this tutorial, we're just going to take things really slow. We're going to look at specifically at the domain and adding entities to the domain. Okay. So what I have here is a very simple setup. I've got a plane and a half sphere I've put into the scene. Oh, another important thing we're going to cover in this is scale. Scale is very important in Deep Rising effects. So let's begin. So what I'm going to do is open the domain window. I won't use the shortcuts just to make sure everything is clear. You can always use them after you understand how everything works. Okay, let's get started. So what I want to do is add these two objects as rigid objects to the scene. Okay. Deep Rising already included the fluid cache for me, which is very important if you watched the last video, and a mesh reference, which will be important as well later on when we get into meshing particles. Okay, so what I'm going to do is actually just to add them one by one, but what you can do also is just select both of them at the same time, go to edit and add selected item, but I'll do them individually so you understand what's happening. So I'm going to start with the plane. I'm going to say add selected item to give me a list of things I can include. So you got rigid objects, fluids, and granular. So we're just going to start with rigid objects. I'll press OK. Bam. Then we're presented with our first problem. Okay. Deep Rising only accepts triangulated meshes. So what we have here is all quads. So this is easily fixed if we just open modular. To open a few seconds. It's very important to get your meshing correct. So as you can see, there's no triangles. A quick way to fix this is just to go to multiply, and then under subdivide you say more and convert polygons to triangles, and to convert everything to triangles. And we're just going to save object, and we're ready to go. And close modular. I don't know what happened there. Anyway, I can carry on. It was modular. I don't know what happened there. So I will select the plane again and go to edit and add selected item, rigid object, and after that it to add our rigid object. Now we're gonna just go through the settings of what's just happened here. So there's a little handy feature in Deep Rising that allows you to look at the collision particles. Now everything is a particle in Deep Rising effects, so even SPH, like I said, was particles. So even the collision particles are actually, the collision rigid objects are actually made up of particles. So when I say show collision particles, we're going to see the collision particles. So if I just go to bounding box for a second to have a clear look at what's going on. So as you can see, the plane has been subdivided nicely into a nice array of particles here, okay? And we can see the number of particles is roughly 8,000 particles. Okay, and the type is static, of course. We'll go into the details of rigid objects in another lesson. I'm just going through the basics of rigid objects. And the particle spacing is 0.045. We can talk about the particle spacing and units and the sizes in Deep Rising effects, which is very important. Okay, so by default, all fluid particles in Deep Rising, even granular, you can keep this in mind when we look at granular objects, by default have got a diameter of 20 millimeters or 2 centimeters, and that value is constant throughout the whole domain. So even your collision particles will have the same diameter of 2 centimeters. But what happens sometimes when you simulate and when you do things like this in any package, things will start penetrating or things will start going through. And one way to fix that is to make the spacing between stuff smaller. So this particle spacing here allows you to, for rigid objects specifically, allows you to make the spacing between particles less. They can actually intersect. So another important thing about rigid object particles, static particles, is they can intersect. Okay, so even though they're 2 centimeters, which is 4 centimeters the width of them, they can actually penetrate. They can they can intersect with no problems. That will not affect your simulation. Deep rising will handle the details for you, which is very important. So by default, there'll be 0.05. There's a little gap there, which is not important most of the time. But if you see particles going through, you would increase that. And then the second most important thing is the sampling type. So for fluids or SPH, you mainly use voxels, which is recommended. Okay, but there's also plane. The advantage of plane is less particles, of course, and you've got the more uniform triangular look at it, of course. But it's mainly meant for granular particles. Even you can still use it with fluid dynamics, but what happens most of the time because of the sampling pattern is particles will go through, especially if you've got concave or convex types. Particles will most of the time go through the geometry, and it's really hard to fix. So recommended for all fluids is just to use voxels. Okay, hope that made sense. I'm just going to go back to textured solid, and I'm going to add the half sphere. So I'll go to edit, add selected rigid object, and let me just go to bounding box again so you can see this clearly. We've got our half sphere now in the scene, so we've got two rigid objects. Wonderful. So next we want to actually simulate something. So I'm just go back to texture solid. I will go to hide the rigid objects since we know they're there. So what we're going to do is add an emitter. So we're going to go to add entity, and an entity type will be emitter. Press OK, and this will give us our emitter. So I'm just going to move the emitter to the side, and I'm going to select it in the domain to look at the settings. Okay, so the particle emitter emits fluid particles, and just like the boundary particles, the default diameter is 2 centimeters and the width is 4 centimeters, and that is a constant throughout the simulation domain, so that will never change. What I'm going to do here is just put in 0 and press enter, and that will give me the smallest possible emitter, okay, which will be 0.043. Then I'm just going to aim it at our obstacle. I'm just going to position it, okay, and then I'll talk about the settings here. Okay, for the emitter, emitters are very straightforward. There is one important difference between deep rising effects emitters and light wave emitters. Since particles cannot intersect in SPH, as we talked about in the first video, when particles are emitted, they have to have equal spacing, so they will not come out. They won't be intersecting. So that means you can have settings like birth rate, because having a value like birth rate, for example, means particles can be spawned at different places, and if they're spawned at different places, they can intersect and the simulation will explode, because SPH is not just a particle system, it's actually a physical simulation. Okay, hope that made sense. Okay, so there's two types of emitters, of course. There's a square emitter and the circle, which they function exactly the same except for the shape of the emission. We'll mainly work with circle emitters since it's roughly the same. And then the particle limit is how many particles the emitter will emit in a lifetime. So I'm just going to drop this to probably like 500 because for demonstration purposes. Strength is just the strength and force, so that's the force. So that would be 10 units. Oh, that would be 10 units per second, or 10 meters in light wave scaling, if that's correct. Even from a physical standpoint, I'm just going to drop it to 5. And then random UVness, for this we don't need it, we're gonna drop it to 0. What randomness does is just destroys the pattern for the emitter. I'll show that later to demonstrate that. And of course the radius of the circle is just the radius. And then we're ready to simulate. Okay, so another thing, if we go to the fluid cache, I haven't talked about the fluid cache, which is very important. You need a fluid cache to save and show your results after they finish. Okay, and by default everything will be saved to memory. Okay, and with that you can simulate. I'm going to close the domain panel now and go to the solvers domain. We're not going to change anything here. We're going to use the default settings and just hit the simulate button, and then we see our simulation running. And as you can see, we've got the SPH particles being emitted from our emitter, and they collide with the rigid object particles, and they bounce off and behave like fluids, like we talked about in the first part of this training course. So everything we talked about in the first video, of course, is happening here. Each particle has got a velocity, mass, and then every time it collides with another particle, whether if it's a boundary particle or fluid particle, it's going to do the calculation of pressure, do its Navier-Stokes equation. It's going to solve that and make sure everything is physically correct, so you get things that look like fluids. Okay. So we'll just let this run for a bit more, so we can demonstrate the fluid cache. 1 second. Okay, we're nearly done. Okay, and done. So I'm just gonna close this in the solver window and rewind this. So once everything is saved, you can actually just scrub through it. This is the power of the fluid cache. It's great for looking at your simulation and see what it comes out as. So as you can see, we've got our smooth particle dynamics, which is cool. Okay, so with that is your first SPH simulation, or first simulation in deep rising, if this is your first time using it. And okay, I'll see you in the next video. I hope you enjoyed that. See you soon.